Hi class, so welcome to another video, and today we're going to play with probability. Okay, now probability could be a little bit tricky because here we're anticipating what are the possible outcomes of a certain scenario. Take for example, what is the probability or what is the chances that it's going to rain this afternoon? Alright, so if you're going to think about it, you only have two outcomes. So it's gonna be to rain or not to rain. So you only have two. Which is no rain or rain. So we count them as 1 and 2. So you're only going to expect one scenario out of these two. So that's gonna be, it's gonna be no rain or it's gonna be raining. Therefore, the possibility or the chance of getting one out of these two is only 1 over 2 or 0.5 times 100%. That is obviously 50%. 50%, right? But if you're going to check on Google what are the possibility of getting rain or chances of rain today, weather forecast, sorry. We're going to ask Google for the weather forecast. John. Right? So if you're going to look at it, we'll be given a 20% precipitation. So what are the odds really? Chances, weather forecast, chance of rain. Yeah, chance of rain. So 20% chance of rain. Alright, so if you're going to think of it, you're only going to expect two. You're going to expect one. It's gonna be uulan ba o hindi uulan. So it's gonna be 50%. Now, why is it that we're seeing 20% precipitation? Alright. Well, this happens because weather forecasters take into consider not just rain or no rain. They're actually considering a lot of stuff or factors. Now, if you're going to think of it, now, going back to the science, now, diba, we start with, wait lang, gagawin kong blue. For example, yung water natin, at meron tayong araw. Okay? Hindi yan itlog, araw yan. So, yung init or yung sunlight will or heat rather will cause the water to evaporate. So magiging water vapor yan. Aangat yan, magiging magko-accumulate yan, magiging clouds. Okay? So paano nangyari yung rain? So if we're going to review our science, magiging rain yan, magda-drop yan as rain. Magiging rain yan kapag bumigat na yung clouds natin. So through condensation, which is yung mainit na hangin, ay kapag biglang lumamig yan, magiging yung water vapor magiging liquid. So kapag naging liquid yan, mag-iipon-ipon sila at magda-drop sila as rain, so precipitation. So maraming factors na nagpi-play dyan. We can think about for example, one very important factor to consider is the pressure or atmospheric pressure. Kung narinig nyo, no, so may mga low pressure area or high pressure area. So kapag low pressure area tayo, kapag low P, or let's say low LPA, because LPA, so yan, malaking chance yung pag-ulan or yung pagbuo ng mga bagyo. So kapag high pressure naman, so very less chance na magkaroon na mabuo yung bagyo kasi ayaw ng mga bagyo sa mga high pressure area. Kasi hindi mag-condensate yung water vapor sa ganung klaseng pressure. So kung isipin natin, maraming factor. For example, humidity. Okay, so mayroon humidity dyan, so 79% of the water, so sinasabi dyan basically is yung ating atmosphere, pagsukat nila, nakuha nila na 79% dyan sa atmosphere na yan is water vapor. So dyan nasabi yung humidity. So nagiging nagbabago yung, so technically speaking, nagbabago yung prediction ng mga weather forecasters dun sa ating weather. So hindi sila lagi nagsasabi, okay, 50% chance rain, kasi pwede naman, kasi isipin nyo naman, no, kapag sinabi ng weather forecasters 50% chance of rain, so 50%, the rest 50% is hindi uulan. So para kang tanga, so you're torn between the two options. So ilan ba chance na uulan? 50%. So 50% din na hindi uulan. So nagbabago yung prediction due to several factors. So one factor na may isip ko as a non-weather specialist is syempre pressure, temperature, humidity. Yan. So maraming factors sa play. So I don't know, maybe they're using some kind of formula na makukuha nila yung actual na percentage ng chances of rain. Alright? So, but we're not going to dig on those things because we're not weather forecasters. We're not weather scientists, by the way. So, going back on the lecture, okay, so we're going to talk about probability. So, this is the kind of probability that is not going to be, tossing dice or toss coins, more of like that, but this is like a mathematics style of probability. So so here we're going to understand and describe sample spaces. So what are sample spaces? So we're going to encounter sample spaces. We're also going to encounter events. So we're going also to interpret probabilities and use probabilities of outcomes to calculate probabilities of events in discrete sample spaces. So by the word discrete is discrete is specified range of values. So hindi pwede dito yung infinity. Ganun. So it's only finite. So when you talk about discrete, it's finite. So also we're going to interpret and calculate conditional probabilities of events. So use Bayes' theorem to calculate conditional probabilities and understand random variables. So for the first lesson is we're going to talk about sample spaces and events. So what are sample spaces and what are events? So the book gave us an introduction here. So it says here that if we're going to measure, for example, a current inside a wire, okay, sa mga electrical makaka-relate dito. So yung copper wire. Right? So yan ang copper wire, for example, with it has a particular length, which is L, right? So if you're going to make a daily record of the copper of a current across the thin copper wire, okay, it's going to change. So ibig sabihin, if we're going to make a graph, so let's say this is Monday, this is Tuesday, this is Wednesday, this is Thursday, and this is Friday or Saturday, so forth. So this is yung amount of current. So this is amperes or amps. So let's say sa simula, meron tayong na-record na ganyan. So naman is ganito, and ganyan, 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 ganyan. Mapapansin nyo, nagbabago-bago. So ibig sabihin niya kasi there always be variability in our observations because again, it's nothing fixed. So naalala nyo naman example ko dun sa thermometer, no? So sa infrared thermometer, so kahit there will always be a slight differences in the measured temperature because of variability. Now here, the amount of current that we measure across that flows in this wire, okay, ito lang. Let's say we have a source here, a voltage source. Alright, so if we're going to use an ammeter, which is symbol A, So, yung may measure natin na current dyan is nagbabago. So, ito yung may measure natin current. So, ito yung ating tinitingnan ng ating mga mata. Alright? So, yung na-measure natin na current, yun ang ating observation ay tinatawag natin na experiments with a random component. So since nagbabago yung value ng ating current na na-measure, we can say that it is a random component. So, yung current na nagpo-flow dito sa wire na to ay hindi consistent. Now, the formula for current is given by Ohm's law. So, Ohm's law says that the amount of current passing through any object or to a particular circuit is directly proportional to the voltage, and it is inversely proportional to its resistance. Now, going back to our physics, the temperature of a material affects the resistivity or the resistance of the material. So, if there are changes in temperature, we can also expect changes in the value of the resistance of an object. So that is the reason, or this variability is the reason that our current is also changing. Right? So no matter how carefully our experiment is designed and conducted, the variation is almost always present, and its magnitude can be large enough that the important conclusion from our experiment are not obvious. Alright, so ibig sabihin, there will be time na it will, we always expect that our current or the current that flows through our wire is always constant or always consistent. But there are times na kapag nagbago yung ating current, so there might be changes in other factors, such as baka kasi naputol yung wire natin, umikli, o pwedeng humaba yung wire, ganun, or pwedeng yung ating voltage sources nagbago. So, mapansin nyo naman sa formula, di ba? Kung nagbago yung voltage source natin, magbabago yung ating current because it's directly proportional. Whereas, kapag nag-ikli yung wire natin, so mababa yung resistance, so magtataas din yung ating current, magbabago yung current. So yun ang point. Okay, so naalala nyo naman, there are many ways that we can make observation about something. We can use empirical models. Yung sa first topic, sa first week, pwede tayong gumamit ng mga formulas, yung mga Ohm's law, mga ganun. O pwede rin tayong gumamit ng, pwede rin tayong mag-observe, or pwede tayong gumawa ng sarili nating formula by merely or by doing series of experiments. So pwede rin naman yun. Because either way, okay, naman lang siguro. Our goal is to understand, quantify, and model the type of variations that we often encounter. So when we incorporate the variation into our thinking and analysis, we can make informed judgment from our results that are not invalidated by variation. Okay, now, so let's say na hindi natin alam yung formula na, okay, maisulat ko lang ulit. So let's say hindi natin alam yung formula na I is equals to V over R, no? So let's say hindi natin alam yan. Pero, pero, meron tayong experiment na ganito. Okay, so ayusin ko na siguro yung drawing. So, meron tayong length. So, let's say, ang initial length natin is so natin 5 meters. Tapos, ang resistance niyan, let's say, resistance niya ay 5 din. 5 ohms. Tapos, nagputol tayo. So, naging, sabihin 4.5 meters. Tapos, ang resistance niya ay, sabihin natin na nabawasan din siya ng 0.5. So, magiging, sabihin natin na ay 4 ohms. Tapos, L2. Sabihin natin 4 meters. And, ang R ay naging 3 ohms. Right? So, sabihin natin na meron tayong tatlong putol. So, unang putol. Okay, bura muna. Okay, let's say, unang putol. Ito yung sa unang putol. Then, pangalawang putol. Then, pangatlong putol. So, i-clean na yung ating wire, no? So, kapag may-clean na wire, okay, so, unang putol. Baliktad yata ako. Hindi pala putol to, pahaba pala to. Oo. Tama. Dito yung ating L0. Ito yung ating L2. So, dati, dito tayo sa 5 meters. So, dadagdag pala tayo. Sorry. Dadagdag pala tayo. Alright. So, dati, 5 meters. Tapos, naging 6 meters. Tapos, naging 6.7 meters. Right. Okay. So, ito yung resistance. Tapos, resistance, current. Focus okay. Alright. So, for example, kapag at 5 meters yan, L0, sabihin, let's say ang ating current dito, current pala, ang voltage natin na measure, let's say 12. Tapos ang volts natin naging 13. Tapos naging natin na 14. Ganun. Volts. Tapos ang gagawin natin next is plot natin yung ating recorded values. So let's say this is the voltage, this is the resistance. So this is the voltage and this is the resistance. So sabihin natin dito yung 5, 6 and then 7. Sabihin natin na dito yung 14, then 13 and then 12. Okay, gamit tayo ng red. Okay, so for example, sa una natin scenario, so kapag ina-measure natin dito ay 5 lang. 5, ito naman yung 12, tama. Ito yung 14. Ito naman yung wait lang, baliktad pala. Ito yung 3. Ayan, sabang sa so, dapat ito yung 3, then ito yung 5. Okay, so na-measure natin at 3 ohms yung ating voltage ay 14. Tapos, nung naging 4 yung ohms natin, naging 13. Tapos, nung naging 5 ohms tayo, naging 12. Alright. So, mapapansin ninyo, magiging straight line yan. Okay? Zoom natin. Labo pala, pixelated. Right? Now, so, if we're going to observe the graph, papansin natin na yung voltage at yung resistance ng ating wire is nagkakaroon ng parang linear behavior. In way na kapag mag-measure tayo ng magbibigay tayo ng any value is magiging straight line yon. So magiging linear na ganyan. So kapag na-observe natin ng ganyan, isa lang naman iisipin natin, no? So it's constant na ganun. So straight na ganyan. And we all know, going back to our analytic geometry, na lines have their own slopes. Okay? So may slope. So merong slope yan. And everything that has slope, it means it's changing. So may gradient. So sabi nga nila, kapag slope, it's also the gradient. Kung maalala nyo, delta. Or, in this case, slope is m. No. So, if we're going to review analytic geometry, so slope is the change in y over the change in x. So, parang baliktad yata ako. Okay, change in y over change in x. Therefore, our change in y here is the changing voltage and the changing resistance. And kung papansin niyo, no, sa changing voltage over changing resistance, so parang medyo hawig yata ito dun sa sa formula ng Ohm's law, which is I is equals to V over R. So, di naman siguro sasabihin coincidence, but probably dito nila na-derive yung formula. Dito na-derive ni George Simon Ohm yung formula ng Ohm's law. Kasi sa kaka-experiment na nun, kakaputol-putol niya ng wire, tapos kakasukat-sukat niya ng voltage, tapos yung plot niya, doon niya nalaman na, meron palang relationship yung voltage saka yung resistance. So, he said that the current that flows through a wire changes as its voltage with inversely proportional to its resistance. So, the more na lumiliit yung wire, the more na tumataas yung ating current na nag-flow. Hindi lang yung ibig sabihin doon. But the point really here is, we can use observations in the physical world to make a formula which can be used across any kinds of situation. Diba, nalala nyo naman itong Ohm's law is ginagamit talaga siya. But the concept here is, it could be na-derive natin yung formula through experimentations, which is parang ganoon naman talaga yung sources ng observation sa mga scientists before. Because scientists before are conducting several kinds of experiment extensively. So, maalala nyo yung story ni Galileo, mano-mano niyang sinukat yung mga distances or yung mga displacements and movements ng stars. Kaya niya nasabi na ang center ng ating solar system is the sun and it's not the earth. So, sinaga, binuno, ma'am, kasi nung panahon kasi, ma'am, yung panahon kasi noon, iniwala sila na earth yung center. Yes, yun yung, oo. Sa Galileo yun, ma'am, eh. So, nagkaroon ng conclusion si Galileo through his observation. So, isa-isa niyang sinukat yung mga positions ng stars and then yung moon. Kaya doon niya nalaman na, ay, bakit ganun? So doon niya nalaman na yung Earth is not the center of the universe. So, nalaman niya na it's the sun that is center of the solar system. Alright? So, wala siyang formula noon, but he only used observations and measurements and could be statistics at that time to get conclusion. So, I'm sure nagigets siya naman siguro yung point niya. Alright. So, yun yung point. Okay. So, continue. So, our goal is to understand and quantify the model. Okay. So, pag sinabi nating model, alright. So, baka kasi naisip nyo yung model, yung mga sumasayaw-sayaw sa TikTok. Hindi yun. So, the model in mathematics is basically the formula or equation. So, the model of something is the equation of something. So, nakadepende kasi sa equation yung magiging structure, magiging itsura ng isang bagay. So, anything has its own model because everything has its own formula or equation. Now, if you are very particular, very good in observing things, there are patterns. Okay, so going back to your previous mathematics of the modern world, I think you talked about patterns in mathematics. Basically, so patterns. There are patterns. There are patterns because things follows models, and when we say model, may formula, may equation. All right. So things have pattern, formula, equation. All right. So yun ang ibig sabihin dito. And our quest as engineers or statisticians is to determine or to find out the formula or the model. So, everything has a model. For example, yung pag-ulan, may model yun, kaya nga napipredict eh. Kasi there is a model. But not all kinds of model are perfect because models determined by scientists or the scientists to experiments can be refined. So, pwede pa natin i-improve yung model. For example, pwede siguro maging thesis, no? Make an accurate model of, I don't know, more efficient, I don't know, pwede siguro maggawa kayo ng model nyo na mas effective or mas accurate kaysa dun sa existing models sa mga weather forecasters. Mga ganun. Mga ganun. Diba, Jay? Mga ganun. So, anong araw? So, models and analysis that include variation are not different from models used in other areas of engineering and science. Kasi again, variability is normal. So, normal na yun. Expected na yun. Figure 2-1 displays the important components. Okay, so looking at figure 2-1, so this is the continuous iteration model between model and physical system. Now, if you're going back dun sa ating example kanina, which is the copper wire. So, through experiments and observation, nakuha natin yung model, which is the formula. Yung model na yun is basically yung kanina nga. So, I is equals to V over R. Ito yung model na nakuha through our observation dun sa mga plots natin, sa mga plotting. So, using physical system, so if we're going to do measurements in our physical system, we can create model, so gaya nung kanina. And based on our model, we can create analysis to further understand the physical system. Ha? Ha? Ano? Bye-bye? Bye-bye? Oh. Wait lang.
Hindi naman nakasusi.
Tinamalan ako sa inyong susi. Ano? Kaso di ko naman nalala yung susi. Ano susi? Oh, ito yung susi. Kaya yung bike ka? Oo nga. Kasi pinalak mo, baka manakaw. Uso pa naman ang nakawan ng bike mo yung tanong. So, okay, sorry sa interruption. Sa figure 2-2, so noise variables affect the transformation of inputs to outputs. Now, ingatan mo yung bike kong bebe. Bye-bye. Alright, so control variables, input, so noise variables, output. Example nito. System input, output, noise variables, control variables. Siguro balik tayo doon sa paggawaan ng beer. Okay. For example, yung paggawaan ng beer natin last time. So, output natin yung beer. At yung gusto nating makuha dun sa beer ay yung lasa, yung taste. No? Tapos meron tayong controlled variables, yung tatlo, yung ating water, yung ating bacteria, at yung ating malt. Alright, so meron tayong mga noise variables. Ano kayo mga noise variables pagdating dito? Ano, may could be yung old, yung pwede siguro dito yung age ng machine, no? Also, pwede siguro natin dito gawin yung siguro yung temperature, external factor. Okay. Sorry, parang mali yata ako. Mali ako. Hindi pala ganito yun. Sorry. Okay, so balik paggawaan ng beer. So yung mga input natin, yung mga raw material natin, at yung output natin ay yung beer. At yung gusto natin makuha sa beer ay yung taste. So yung input natin, meron tayong water, meron tayong bacteria, meron tayong malt. Okay? So meron tayong mga control variables, no? So yung mga control variables dyan, pwede natin sabihin na controlled natin yung quality at yung quantity. Pero yung mga noise variables natin, yung hindi natin na-expect, no? Pwede kasi yung hindi naman na-expect, pwede kasi maka-apekto. So, dito yung age ng ating machine at yung temperature. Okay? So, ito, maka-control natin yan kasi pwede natin silang, for example, ano ibig ko sabihin ng control? So, yung quality kasi, we can select the quality. Okay? So, yung quantity is measurable. So, ibig sabihin, sukat na natin kung gano'ng kadaming tubig, gano'ng kadaming yung malt, gano'ng kadaming bacteria. So, yun ang ibig sabihin ng control variable. So, yun yung mga bagay na, kontrolado mo. Okay? Translate ko lang. So, yung noise variables naman, yung mga bagay na, hindi natin may iwasan, nandyan talaga sila. Kasi, siyempre, tumatanda yung machine, no? So, nakaka-apekto yung tanda ng machine sa ating production. So, it could be na di na efficient yung machine. Ganun. So, efficiency. So, temperature. Yung mga slight changes sa temperature, nakaka-apekto sa beer production. So, yun yung mga noise variables na hindi talaga natin may iwasan. Because they exist. Okay? So, yun ang ibig sabihin yan. Figure 2-2. Okay, so figure 2-3 naman is a closer examination of the system, identifies deviations from the model. So, kung mapapansin nyo kanina, no, ito na yung ina-expect natin kanina. For example, yung example lang naman to ng current voltage. Okay. Babalikan natin kasi yung formula, I is equals to V over R. Ito kasi yung kinuha ko kanina. Pero kung ta-transpose kasi natin or i-manipulate natin yung formula, pwede naman magiging R is V over I. Okay. Or pwede natin sabihin na V is IR. Okay. So, example lang naman yan. But the point here, dito sa representation ng image is, nakikita nyo yung line na yan, itong line na yan, yan lang yung ating expected. So, expected. But again, since not all things are 100% sure, because there are still things that we are not certain about, kaya nga may probability. So, how likely? So, since hindi tayo 100% sure, meron pa rin mga measurements na hindi magpo-fall dun sa ating expected, which is itong line na to. So, hindi natin na-expect yan. But however, that line is a good indicator. So, maganda ng prediction or model prediction yung line na yan. So, because, ano bang point niyan? Because any value can be near that line. So, it can be here or it can be here. So, hindi siya perfect, but it is a good way to predict something. So, yun yung ibig sabihin niya. So, hindi ko na-elaborate dyan kasi mga call minutes, instructions. Okay? So, sabi dito, an experiment that can result in outcomes, or ibig sabihin, outcomes na hindi natin na-expect, even though it is repeated in the same manner every time, is called random experiment. So yung mga ginagawa nating measurement, experiment na pala yun. So, yung pagsusukat-sukat natin, temperature natin, experiment na rin pala yun. But, hindi natin alam, experiment pala yun. So, these are the things that we call random experiments. So hindi tayo nagkakaroon sa pare-pareho measurements every time. So, always, we're not getting the same measurement. So, it's a random experiment. Okay, so now that you understand na there are really things that talks about accuracy and then prediction. So, very important prediction. So, for example, if we get data from observation, okay, so for example, this is the time and this is our observation, and this is our observations in post time. We can make a prediction. We can certainly make a prediction based on the following patterns, because makakaroon lang tayo ng pattern kapag meron tayong enough data. Okay, so ito yung isa sa benefit ng retrospective study, because yung retrospective study gives us a wide variety, masyadong a comprehensive number of data. So from that kind of data, we can create a model na kung saan mapipredict natin yung pwedeng mangyari. Again, data from observations. So, from these observations, we can make models. Ito yung model natin. So, yung line na yan. And we can use that model to predict future events. Or to not really predict 100%, but we can predict it with a certain degree of accuracy. So, yun yung mga predictions natin. So, that is on the topic of probability. So we will know a lot of predictions and probability models as we go along the topic. And for now, we're going to talk about sample spaces. So what are sample spaces? So to model and analyze a random experiment, we must understand the set of possible outcomes from the experiment. So the set of all possible outcomes of the experiment is called the sample space. So ibig sabihin, lahat ng posibleng mangyari, yun yung sample space. Okay? For example, parang ganito. So, if we talk about sample space, is we are controlling what is going to happen. So, we put, for example, ito yung bola ng basketball. So, we put that ball inside our own enclosed box that we are predicting every possible outcome ng pwedeng mangyari sa ball. Yun yung ibig sabihin. So, pwede ba ang ball mag-roll? Pwede ba yan mag-dribble, mag-bounce? Kung mag-bounce, ilang number ng bounce? Kung mag-roll man siya, ilang number of rolls? So, yun yung ibig sabihin ng sample space. So, we're talking about numbers. So, how many? So, the sample space is denoted by the letter capital S. Okay, so when we talk about so when you see a big letter S, so that is sample space. And again, sample space is all the possible outcomes. All right? So a sample space is often defined based on the objectives of the analysis. Yeah, again, pag may ball tayo, na-expect lang naman natin na mag-roll siya or mag-bounce. So hindi naman pwedeng maging lumipad yun, di ba? So we are only expecting what are the possible, yung mga doable. So it really defines on the objectives of the analysis. Now going back to the drawing kanina. So di ba sabi ko, pwede siyang mag-roll o pwede siyang mag-bounce. So, pwede siyang mag-roll. So, if we're only going to talk about kung ilang beses siya mag-roll, edi yun lang. So, hindi mo naisipin kung ilang beses siya mag-dribble. Alright? So, iisipin nyo lang kung ilang beses siya mag-roll, ilang ikot siya, because that's your objective. Iba naman kapag if you're going to have an objective na gusto mong malaman kung ilan yung bounce. So, kung ilan ang bounce, huwag mo na papansinin yung ikot. Okay? So, yun yung point dyan. So, nakadepende yun sa iyong objective. So, consider going back to our experiment kanina. Okay? So, we can say that the sample space for a certain material that we are measuring, for example, may measure nyo yung temperature ko using a thermometer. So, lahat ng possible temperature dyan, yun. So, you can say R+. Where all the possible values are greater than 0. Ano ibig sabihin yan, sir? Okay, so interpret natin, breakdown natin. So, for example, ito yung sample space. Ito yung S. So, lahat ng possible outcomes, diba? So, kapag i-measure, si Mar, diba kapag i-measure nyo ako, so i-measure nyo yung temperature ko, it could be 34, it could be 35, it could be 37, it could be 20, it could be 25, it could be any number. Right? So, for example, kaya kong umabot ng 10,000 degrees Celsius, edi okay. So, yun yung ibig sabihin nitong R na yan. So, R represents any number. However, that number is limited by this, is defined by this range. So, ibig sabihin yan, X is greater than 0. So, ibig sabihin yan, yung magiging measurement nyo is anything greater than 0. So, ibig sabihin, hindi nyo ako pwedeng sukatin na may negative 30 degrees Celsius. Kasi ibig sabihin, patay na ako nun. Yung mga ganon. So, ibig sabihin yung mga may measure nyo sa akin is puro positive values lang, which is greater than 0. Kasi pag nag-0 naman yung temperature ko, is either nag-yellow na ako. So, di ba, degrees Celsius, nag-yellow na. Okay? So, yun yung point. So, because a negative value is cannot be occur. Okay? So, ibig sabihin naman itong nakikita nyo dito, S or the sample space. Sample space, thus the value for the sample space rather, is any number which is on the range. Ay, kumubura ng curve. So, ibig sabihin, yung value ng ating sample space is anything which is between 10 and 11. Kasi, any number with, okay, so ibig sabihin ng x is, the 10 is less than x. So, ibig sabihin, pwede natin sabihin na x na yung 10.1. Okay, balikan natin. So, ibig sabihin yan, yung x, dito tayo mag-focus sa x na yan, no? Kasi x is a variable which could be any number. But it is defined or restricted by these numbers and its symbol. Okay? So, dito, x daw is greater than 10. And x is less than 11. So, iisipin nyo, their sample space is anything between 10 and 11. Ano ba yung mga 10 between 10 and 11? So, pwede sabihin na 10.1, pwede sabihin na 10.2, pwede sabihin na 10.00001, mga ganun. So, any number which is between 10 and 11, yun yung value ng ating sample space. So, yung ibig sabihin niya. So, dito naman, you can say that the value of a sample space can be low, medium, or high. For example, yung temperature ko. Oh, sorry. Low, medium, high. For example, if your objective, so yung objective natin is only to know, if our objective is only to know kung yung alam mo yung gano'n ka-extreme, so gano'n ba kababa yung temperature na pwedeng ibaba ng temperature ng tao. Let's say, sabihin natin ang pinakamababa based according to science, hanapin natin kay Google. Lowest possible temperature of the body. Okay, so this is 13.7 degrees. So the lowest possible is 13.7 degrees. So natin 13.7, 7, and the highest. Okay, highest. Natin ang highest. Highest is 1. Celsius 115. Okay, ilang Celsius yan? 46. Tapos yung high natin ay 46.11. So ibig sabihin ng medium natin, pwede natin sabihin na between 13.7 and 46.11. So if you're only going to be kung ang gusto niyo lang naman is malaman kung yung temperature ko is low, medium, or high, ito yung gagawin yung sample space. Kasi ito lang naman ang ina-expect nyo. Kasi ito yung mga ina-expect yung possible outcomes. So, dito naman, for example, dito naman, what if your sample space is only yes or no? So, pag magiging yes or no lang yan, for example, si Sir ba ay may COVID ba? Okay, so ako may COVID-19 ba ako? So, ibig sabihin ng sample space nyo, you're only going to expect an answer which is a yes or a no. So, kapag lumagpas ako sa 37 degrees Celsius, it's a yes. So, kapag bumaba ako sa 37, mababa ako sa 37 degrees Celsius, it's a no. Okay, so yun lang yun. So, again, sample space is all the possible outcomes that you are expecting. But it depends on the objective. So, hindi lahat kasi kukunin nyo. Magiging specific lang kayo sa objectives na kailangan ninyo. Yun ang ibig sabihin yan. Yung mga yan. Okay, so it is useful to distinguish between two types of sample spaces. So, the sample space is discrete if it only consists of a finite or countable infinite set of outcomes. Okay, so discrete kapag nabibilang. Sample space is continuous if it contains an interval, either finite or infinite, of real numbers. So, yun naman continuous. So, it could be continuing. So, discrete kapag may range lang. So, it can only exist on a certain range. So, gaya nung kanina, our sample space can only have a value wherein the x is 11. So, papansin nyo, yung value ng 10 is only between 10 and 11. So, any numbers between these two, yun yung sample space na ina-expect natin. Right, so, for example, if two connectors are selected and measured, the extension of the real positive value of line R is to take sample space positive quadrant of the lane. So, kapag two connectors, we multiply. Okay, so we multiply the sample space possible. Okay, so if the objective of the analysis is to consider only whether or parts conform to the manufacturing specification, either part may or may not conform. So, ibig sabihin lang yan, ganito. For example, meron tayong dalawang tubo. Sabi natin tubo number 1 and tubo number 2. So, based dito, we're only going to compare two kinds of material or object. And all the possible combinations, ito na yung sample space. So, all the possible combination of this, so sabi dito, it may or it may not conform. So, could be, pwede natin sabihin na yung number 1 natin is, let's say, sabihin natin na, yes, it conforms. So, yung number 2 natin, no. So, sa pangalawa natin, pwede natin sabihin na yung number 1 naman is hindi nagko-conform, yung number 2 naman nagko-conform. Okay? So, pwede rin natin sabihin na silang dalawa ay nagko-conform. At pwede natin sabihin na lahat sila ay hindi nagko-conform. So these are all the possible outcomes na pwedeng mangyari. So it could be, so ibig sabihin yan, it could be that one is sira and number 2 is okay, or it could be number 2 is sira and number 1 is okay. It could always also mean that it could be na number 1 is okay and number 2 is also okay. Now it could be 1 is not okay and number 2 is not okay. I mean, why is that? Because we are selecting these two out of random. So, pumili lang tayo bigla-bigla. So, kumuha lang tayo sa level sample. Bubukasan tayo ng karton, kumuha tayong dalawa. So, what are the odds? No? Ito yung point. So, what are the odds that we have if we have an okay material or not an okay material? So, ito yung mga expected natin kapag bumunot tayo ng dalawa. Alright? So, ibig sabihin kapag naging tatlo yan, madami-dami na yan. So, kapag magiging tatlo yan, ang ating sample space, nagiging pareho lahat silang tatlo ay yes. Alright? So, pwedeng yes, yes na yung pangalawa, yung no naman yung isa. O yung yes, no, and yes. No, yes, yes. Sunod ay no, yes, no. Ang sunod naman dyan ay no, no, yes. And then no, no, no. So, kapag tatlo yung kinuha nating material sa loob ng isang box, the chances are that we have all the possible outcomes. So, we have 1, 2, 3, 4, 5, 6, 7 possible outcomes. Right, so another example dito is yung mamaya na yan, hindi naman importante yung tree diagram. Okay, so tree diagram. So meron maganda example dito ng tree diagram. Ito, explain ko na lang. So dito sa tree diagram na to, ito yung mga possible, yung mga all the probability or possible different types of vehicles. So ang point dito is kapag ikaw yung gagawa, for example, ako yung Toyota, so ako may-ari ng Toyota, for example, at gagawa ako ng sasakyan, di ba? At tanong dyan kasi ganito, kapag ako ba yung Toyota manufacturer, isang klaseng sasakyan lang ba gagawin ko? Oo, syempre, sir, lahat naman sasakyan, 4 ang gulong eh. Hindi naman yun ang point. Ang point ko is, we customize cars according to preferences. But, you know, ang tao, maraming klaseng preferences. So, may mga tao na ayaw nila ng manual, merong tao ayaw nila ng automatic, so ganun. So, may mga tao na ayaw nila ng may aircon yung sasakyan, may tao na gusto may aircon ng sasakyan. So, may mga tao rin naman na ayaw na may stereo, ayaw na may music kasi gusto nila ay traditional, gusto nila tahimik lang. So, ang iba naman gusto nila kulay blue, kulay red, kulay white, kulay yellow, kulay purple, ang daming klase ng kulay. So, expect nyo naman. So papansin nyo naman, no, di ba, ang weird naman kung ang automaker, for example, Toyota, meron na ba kayong nakita na gumagawa ng sasakyan at lahat ng kulay sa rainbow nandun? Di ba, wala. Wala, di ba? Bakit? Kasi yung lahat ng different combinations ay magiging mahirap. Kasi ibig sabihin, ganito, kung ang automaker ay gagawa ng kung automaker ay gagawa ng sasakyan na meron lahat ng kulay. Okay, for example, ang kulay natin, 5 kulay lahat. How many colors? All in all. Yan daw. O tingnan nyo na, 100 o 1,000 levels. So may mga gradient pa. So may mga fuchsia, may fuchsia pink, may pomelo, may iba-ibang klase. So isipin nyo lang, di ba? Ang daming klase ng kulay. So meron bang mga automaker na gumagawa ng ganun? For example, isipin nyo na lang, ang ang exterior ng sasakyan is kulay violet. So, ang weird naman kung ang sasakyan nyo, labas ay violet, tapos ang loob violet din, di ba? Parang sakit sa mata. So, di ba? Siyempre mga combination yan, yung tinatawag nilang dapat may harmony yung mga kulay, dapat nag-complement yung mga kulay. So, yun yung mga reason kung bakit hindi lahat ng kulay ay pwede natin gawin sa sasakyan. So, pipili lang tayo ng mga primary colors. Now, primary colors could be, I don't know, maybe could be RGBY. Pwede natin magsama ng black or white. Mga ganon. So, papansin nyo yung mga sasakyan, usually mga black, mga white, mga red, mga blue. Bibihira tayo makikita ng green. Bibihira din tayo makita ng yellow. Pero meron, pero bibihira lang. The reason for that is kapag iisipin kasi ng manufacturer yung lahat ng klase ng kulay ay sobrang dami ng sasakyan yung gagawin nila. On top of that, hindi lang yun. Kailangan nyo rin i-consider kung anong kulay ng interior kasi hindi babagay yung yellow na exterior sa kulay black na interior or kulay brown na interior. So, hindi bagay yung gano'n. So, yun ang point ito. So, how to interpret this tree diagram? Okay, so balik tayo dito. So, for example, ang tanong nyo sa customer, sir, gusto nyo po ba ng automatic or manual? Sabi ng customer, manual. Sabi niya, ang sunod naman tanong, gusto nyo ba sir na may aircon o hindi? O walang aircon? So, sabi naman ng isa, yes, merong aircon, so dito tayo. Tapos ito, sir, anong klaseng stereo? Dalawang stereo, isang stereo, tatlong stereo. So, pagpadan, okay sir, anong gusto nyo kulay ng interior sir? Gusto nyo ba ng kulay puti? Gusto nyo po kulay black? Black bar puti? Okay sir, kulay white ang gusto ko. Tapos kapag nakapili nyo na interior, sir, anong gusto nyo ng kulay ng exterior ng sasakyan nyo? Gusto nyo po ba ng white? Gusto nyo po ba ng black? Gusto nyo po ba ng blue? Gusto nyo ba ng yellow? So yun, again, if you're going to talk about this, the whole tree diagram of the automaker, yung isang automaker for a particular model of a car will make at least 48 sets of them. So isang auto lang yan. For example, Nissan, papito. Sakyan. Jay, anong brand saka model ng sasakyan ng ano mo? Gusto mo? Ha? Motor. Wala. Okay, example, ano na lang, Ford Everest. Ford Everest na lang, Ford Everest. So, isipin nyo, kapag gagawa yung manufacturer ng isang Ford Everest, so maraming klaseng Ford Everest yun. Hindi lang yung isang Ford Everest. Kasi mayroong automatic na Ford Everest at mayroong manual na Ford Everest. Mayroong kulay blue na Ford Everest, white, black. So, ang dami-dami. Yun ang point. Alright? So, yung possible combinations ay ito yung ginagamit. So, tree diagram. Dami ko sinasabi. Now, yun yung sample space. So, again, the sample space is everything that you are expecting. So, lahat ng possible outcomes, that's sample space. Now, what about events? So, what are events? So, often we are interested in a collection of related outcomes from a random experiment. So, we are only interested at a certain part of a sample space. So, for example, if we're only going to be particular with something, for example, di ba sample space is all? So, an event is only some of that all. So, for example, ito yung all nyo, so yung event is only a portion of all. So, an event is only a portion of the sample space. So, an event is a subset of the sample space of a random experiment. So, ibig sabihin, a sample space is a composition of many events. Alright? Gets nyo? Okay, yun yun. Okay, so isipin nyo, 100 vehicle, 120 vehicle types. Dami-dami. Alright, so, okay, so, there are three kinds of basic operate. There are three basic set of operations in events. Alright, so, sa events, meron tatlong klase. So, we have union, we have intersection, and we have complement. Now, ano ba itong mga to? So, consider sample space. Yung sample space natin is yes, 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 no, no, yes, no, no. Okay, so suppose that the set of all outcomes for each one conforms to note as E1. So, for example, itong event 1. So, ito lang yung pipiliin natin. For example, magiging favorite lang natin yung yes, 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 no, and no, yes. So, susulat natin yan. For example, natin sample space is yes, 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 no, no, yes, and no, no. Tapos, ang event natin, which is only a portion of the sample space, which is E1 or event number 1, ang pipiliin lang natin ay YY, yes, no, and then no, yes. So, bisag papansin nyo, meron tayong naiiwan na isa. Meron tayong hindi nakuha. Meron tayong hindi nakuha eh. Yung no, no. Okay? No, no. So, yan yung iwan natin. So, the event in which both personal conform, noted as E2, contains only a single outcome. So, papansin nyo, ibig sabihin ng ating E1 natin, or is E2, sorry, is yun yung hindi natin nasama sa E1, obviously, which is no, no. Right, so other examples of the events are E3. Ang E3, it means that null set. So, ibig sabihin ng null set is wala. Wala talaga at all dun sa loob. So, it could be blah, blah, blah. So, yun yung null set. So, hindi siya nag-exist dun sa E1 saka sa E2. Yun ang ibig sabihin nun. E4 is the sample space, where E4 is the sample space itself. And the sample space itself, again, is equivalent to YY, YN, NY, and N. Okay? So, ito na yung mga symbols natin. Now, if we're going to talk about union, so it means, going back to the definition, this union is the two events in which consist all the possible outcomes are contained in either the two elements or two events. So, we denote union as yung U. Okay? So, ibig sabihin ng union from the word itself is pinagsama. So, yung union. So, intersection naman is intersection of two events is the event that consists of all the outcomes that are contained in both of the two events. So, we denote the intersection as E1 baliktad E2. So, complement is yung kuwet. Okay. So, going back. So, dito naman, let's say that E1 and its union, E5. So, E1 union E5 is sample space, the sample space itself. So, tingnan natin dito. So, ano ba yung ating E1? So, E1 natin ito. And ating E5, ating E5, nasa E5 natin. Okay. So, meron pa pala tayong E5. No? So, meron tayong E5. E5 is yes, no, no, yes, and then no, no. So, similar ba sila? Hindi sila similar, no? Kasi merong yes, yes dito, to no, yes, no, yes, no. So, same sila nito. Okay, same sila. So, same sila ng first. So, meron sila nito at nito. Magkaiba lang sila nito. So, no, no dito, dito, yes, yes. Okay. So, dito naman, the union of E1 and E5 is equivalent to the sample space itself. So, if we're going to talk about union kasi, kapag yung event number 1 natin at yung event number 5 natin ay meron silang similar na something sa loob. So, hindi natin pinapansin yon. So, ginagawa natin siya isa. So, papansin nyo, E1 union E5 is equivalent to the sample space itself. Why? Because E1 is yes, 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 no, and no, yes. And our E5 is yes, no, no, yes, and no, no. So again, union is kapag kukumbine tayo ng dalawa, pero kapag merong duplicate, is hindi natin siya binibilang na dalawa, kundi isa lang. So meron tayong duplicate dito. So meron tayong yn dito sa E1. Okay, so meron tayong yn dito sa E1. So isang bilang na lang yan. Magiging isang bilang, yn. So meron tayong ny na dalawa dito. So magiging ny. Itong y ko. At meron tayong yes, yes, yes. May yes, yes ba sa E5? Wala. So yes, yes lang tayo dito. Yes, yes. At no, no. So papansin nyo, ang yes, 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 no, no, yes, no, no is also the same as the sample space itself. So yun ibig sabihin yun. So if you're going to combine the event number 1 and event number 5, we will arrive with the same sample space, which is the original sample space yung S. Yun ibig sabihin nun. Now, how about intersect? So, what about intersect? Okay, so E1 intersect E5. No? No? Alright, so what about E5? E1 intersect of E5. Now, if we're going to look at E1 here, okay, we have this one, and E5. So, the intersect of E1 and E5 is only the terms that are similar. Kung you again, if you're going to think about intersection, so ano yung similar? So, intersect equals similar, okay? So, titingnan lang natin ang dalawang event, okay, yung E1 saka E5, at titingnan lang natin kung ano yung magkapareho, yun na yung intersect nila. So, dito, so meron siyang yn, okay, may yn, check. Yn, so yn. So, yung kaninang union, ito na yung nahanap natin, ha. So, meron tayong yn, check. Meron tayong no, no. Walang no, no dito. So, meron tayong ny, so ibig sabihin ny. So, ito yung union ng E1, ay intersection pala, sorry. Ito yung intersection ng E1 at E5. So, tama ba? Okay, tama. So, what about this one? So, yung dito, complement. So, complement of an event in a sample space is the set of outcomes in the sample space that are not in the event. So, yung wala sa event. So, we denote the component of the event E as E prime. So, yung wala sa events. So, mapansin niyo, di ba? E prime E1. So, if you're going to talk about E1, and it's not included in the subset, kaya mag-E prime tayo, so ibig sabihin, magiging E prime, E1 prime. Ang E1 prime dyan, ang iisipin nyo lang, ang titignan nyo lang, ay yung wala sa subset ng E1, ay nasa loob ng event ng E1, na meron sa subset, sample space. So, pamasin nyo, meron tayong tatlo dito sa E1, sa dalawa, tatlo, at alin yung nawawala dyan, yun lang yung complement. Which is yung value ng E1 complement natin is no, no. Yun lang ibig sabihin nun. Okay? So, more example. Okay, so ito medyo tricky na kasi may values na, ano. So, ibura muna to. So, for this one, samples of polycarbonate plastic. So, baka hindi nyo alam yung polycarbonate plastic, yun yung typical na body ng Realme C3. So, lahat ng mga, madalas sa mga budget line ng C3 phones or Realme phones is polycarbonate plastic yung back. So, unlike sa mga iPhone, mga aluminum, so yun, mga polycarbonate yun. So, matibay pero mura. Okay? So, examples of polycarbonate plastic are analyzed for scratch and shock resistance. So, the results from 50 samples are summarized as follows. Okay. So, ibig sabihin ng ating sample space dito, mga palangga. Okay. Saan na ba yung cursor? Sorry. Ibig sabihin ng ating sample space dito is 50. Kasi 50 naman yung samples natin, yung 50 yung ina-expect natin. So, yun yung mga possible outcomes na ina-expect natin. So, denote that event sample as high shock resistance. So, kapansin nyo, meron tayong okay, so, paano natin interpret to? So, dito, meron tayong shock resistance at meron tayong scratch resistance. So, meron tayong dalawang level. So, high at low. So, merong material na high ang shock resistance at high din ang scratch resistance. Merong material na high ang shock resistance pero low naman ang scratch resistance niya. Yun ang ibig sabihin niyan. At merong mga material na mataas ang, for example, mababa ang shock resistance pero mataas naman ang mataas din ang kanilang scratch resistance. Mataas din pero mababa yung shock resistance. Mababa yung shock resistance pero mataas ang scratch resistance. At meron namang mga samples na mababa both scratch and shock resistance. Okay? So dito, the event A intersect of B consists of 40 samples from which the scratch resistance are high. So, ibig sabihin, sabi dito, yung A, lahat ng A ay high ang shock resistance at yung B naman is high ang alas pala yun SR high ang kanilang shock rest. Ito naman ay rest. Okay? So, dito naman, define the number of samples of A intersect of B, A complement, and A union of B. So, ito yung mga hanapin natin. A union of intersect of B, A complement, at U union of B. Okay, so for A intersect of B, again, sa intersect, if we're going to talk about intersects, yung similar sa event A and B. So, ibig sabihin dito, high shock resistance na nga siya, high scratch resistance din siya. So, ibig sabihin, ang A intersect of B is equivalent to 40 samples. Because 40 samples has both high shock resistance and scratch resistance. So, similar. So, 40 ang may similar. Okay, isipin nyo lang na in reality, ganyan yan. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, hanggang 50. Okay? So, yun. So, 50 pieces yan. So, sa 50 pieces na yan, 40 dyan, ang high shock resistance na meron din high scratch resistance. Yun ibig sabihin. So, A prime naman tayo. A prime. So, ano yung objects? O, ano yung objects na high scratch resistance, high shock resistance, sorry. Ano yung mga bagay na, ano yung mga object na may high scratch resistance, ano yung mga material na mataas ang shock resistance, pero, yun lang. Yung mga matataas lang pala ang shock resistance. Napapansin nyo itong table natin, ang lahat na may mga high shock resistance dyan is 41. So, ibig sabihin, yung hindi kasama sa 41, yun yung mga low resistance, which is yung complement. So, ibig sabihin, ang complement natin dyan is 4 plus 5. Kasi, ang 4 ay low at yung 5 yung dito, pansin nyo dito. So, 4 kasi yung may low resistance at 5 naman yung may resistance. So, ibig sabihin, yan ay 9. Okay? Check natin dito. Tama. So, A, complement composed of 9 samples. Kasi sila yung hindi high shock resistance. So, 9. So, what about A, union of B? Okay, ano naman yung A, union of B? So, papansin nyo, di ba, naalala nyo, kapag union, kino-combine natin. Pero yung mga duplicate, hindi natin pinapansin kasi ang bilang natin sa kanila, isa lang. Right? So, papansin nyo dito, sa A natin is high shock resistance, yung B natin na high scratch resistance. So, meron tayong high shock resistance at high resistance. So, ibig sabihin, papansin nyo, ito yung mga high scratch resistance. Tama. At ito naman ang may mga, okay, copy ko na lang siguro, snapshot. Okay. Papansin nyo, no? Wait lang. Wala kasi yung panel ko. Yung A, union of B, is yung similar na high at similar din na high din ng scratch resistance. So, ano yung mga yan? So, ibig sabihin, sila ay ang total of 5. Oh, sorry. Sila ay a total. So, ibig sabihin ng A union of B are total of 40 plus 4 plus 1. So, sila ay 45. So, ibig sabihin, 45 samples as 45 samples yung union ng high at then yung high shock resistance at scratch resistance na high din. So, ibig sabihin, kung isipin natin, kung isipin nyo, A union of B complement, ano kaya? So, ibig sabihin, yung A union of B complement is yung union ng A and B pero hindi kasama sa kanila. So, papansin niyo, ito yung union ng A and union ng B. At yung hindi kasama sa kanila, yun yung complement. So, ibig sabihin, yung hindi kasama ay 5. Kasi sila yung wala eh. Okay? So, yun yun. So, I hope you get the you understand the topic of the sample space, kung ano yung sample space and how the events, and I hope you understand now how to, what are the basic operations in events. So, union, intersect, and then complement. So, how do we do that? So, for the next video, probably tomorrow, ipapakita ko sa inyo how we do these operations using Venn diagram. So, may mga drawings tayo. So, yeah.